Thank you very much for joining into this webinar, SOFiSTiK with IDEA StatiCa, designing steel connections with SOFiSTiK and IDEA StatiCa. I'm really happy that so much people are joining in here from abroad for this international webinar, and especially I'm also very happy to that we have this joint webinar together with IDEA StatiCa. So with me and my name is Andreas Nigl. I'm working for SOFiSTiK as development manager, and with me is Adam from IDEA.
Hello, I hope you can hear me. So good day, ladies and gentlemen, and welcome to this joint webinar. I'm excited to participate on this event with company SOFiSTiK and their great product, and I will show you how to cooperate between ours and SOFiSTiK softwares. And it's a great opportunity. It's really international. It's Czech and Germany abroad live session, so I'm really excited about this. So thank you for having me here.
Yeah, thank you. Yeah, but before I start, I just wanted to say some words about the GoToWebinar, which we are using as a presentation software. So I think you can hear me. If not, you might want to check your speaker setting here. So you can open up this side panel, or you should see at least this side panel, and which you can open up. And yeah. So you can hear me, but you will be muted during the entire webinar, so you cannot say anything, but you can ask questions. So in that panel, you will also find a question tab, which you can open up here and where you can enter questions. So we will try. There are a couple of colleagues on our side, so from SOFiSTiK as well as from IDEA, who will answer directly the questions during the webinar. And in the end, if there is some time left, we will also try to answer some questions to the audience. And if we don't manage to answer all questions, we are usually then sending out the questions to you after the webinar. Also, that webinar will be available later on as a recording, which you can download either from the SOFiSTiK site or from IDEA StatiCa. Yeah, what we want to show you today? So the agenda. Yeah, first of all, it is twofold. So first I will start presenting, and then Adam will take over presenting you the part of IDEA. And yeah, first of all, I will give you an overview on the workflow. Then I will talk about the data format which we use as an exchange format, the so-called SAF structure analysis format. Then I will explain a little bit more in detail what is being transferred, what are the features of the interface, and then I will go through a SOFiSTiK project which we already set up and show you how you can extract the data and send it over to IDEA. And after that, Adam will take over and will transfer the data. We'll show how to import the data into Checkbot, and yeah, and then we will show how the connection is being set up, and how and he will do the design on that connection. Yeah, first of all, the workflow. So you see here on the left-hand side, SOFiSTiK. On the right-hand side, you see IDEA StatiCa. And yeah, so as for SOFiSTiK, everything circles around or is done within the SOFiSTiK structural desktop SSD. So you see here the SSD, and you will see it later, where you will organize, or where you can organize all your calculations and all your analysis tasks, and you can configure all that task and perform the analysis. And the data or the model which is can be seen here can be entered in SOFiSTiK through different ways. So with SOFiSTiK, we are quite flexible when it comes to preprocessors. So we allow a definition of a model in Autodesk Revit. So we have an interface to Revit where you can model your structure. We do have an interface to Autodesk AutoCAD, which we call SOFiSTiK SOFI Plus. We also have interfaces to Rhino and Grasshopper, where you can model your structure in a fully parametric way. And we also provide an interface using a text language, which is a kind of a programming language, which you can also use to model your structures fully parametrically. So just like a programming language, but which is a little bit more easier to learn than standard programming languages. So these are the different kind of pre-processing options you have in SOFiSTiK. And what you see today, everything is possible with all these preprocessors. So you can, the workflow we are showing today, I'm showing the workflow based on SOFI Plus or AutoCAD, but you can also use Revit or Rhino or the text-based input to do the same. As an exchange format, as already said, we are using that XLSX. So this is an Excel file which follows the structure analysis format. I will quickly, in the next slide, I will show you how this works out. So we are sending just files to IDEA StatiCa, and then in IDEA StatiCa, you can pick up that file and then load them into the IDEA StatiCa Checkbot, where you can then further modify or check the data, and from the checkbot, you will then do the analysis in IDEA StatiCa Connection. Yeah, and we think that workflow, we deliberately did that workflow this way. So having that file format or that file exchange in between, because we think that in general, people will not have or might not have both softwares installed on their computer, and in a standard procedure in an office, also people might not work at the same time, or one people will do the analysis as well as the connection design. So we have two separate tasks which can be done differently on different computers by different peoples. Yeah, as already said, the exchange format is the structure analysis format, SAF. It's kind of a format which has been set up a couple of years ago, I think 5 years ago, based on an initiative of the Nemetschek group to facilitate the cooperation between structural engineers, so mainly led by the software vendor Kia. And the focus is, in contrast to IFC, for example, is entirely only on analytical models. So analytical models to exchange analytical data between analytical analysis softwares. So, for example, you can define analytical beam members, shell members, surface members, together with boundary conditions, loads, results, all what you need to do an analysis. And what we really like in that format is that it is based on Microsoft Excel. So this means you can already read that data. You could also modify that data if you want to. And there's also an extensive documentation. So if you want to check the transferred information, you can check that documentation here, which describes all the parameters and all the information a little bit more in detail. Yeah, so what will be transferred to IDEA in that specific case for doing the connection analysis? So it is materials, of course. You need section information, so the cross section. Then you need the linear members, so either of the full geometry or of a partial geometry, which you can see here, with all the properties and geometry. You need load cases and the forces along the member. So that's what we are transferring to IDEA StatiCa. We will see that later in detail. Let me say some words about materials and sections. So materials and sections, basically, if you use standard materials and standard sections, they will be automatically recognized in IDEA StatiCa. So you can see that here. So we defined the a number of steel profiles here, and these steel profiles will directly be shown up in IDEA StatiCa Checkbot on the right-hand side. And of course, you could also modify them later on. Also, which is question which is asked quite often. Also, eccentricities of the members will be considered. So you can define in SOFiSTiK eccentric members, so either through defining an eccentric cross-section or by defining eccentricities on the member itself. And all those eccentricities will be transferred to IDEA and will be recognized there. But it's also possible, and I think you will see that today, to modify the eccentricities. So you can also do an analysis with centric positions of all the members in SOFiSTiK and then add eccentricities later in IDEA. And what we think is interesting for, especially when you work with SOFiSTiK, I think SOFiSTiK is already known that you can do a very complex geometry and also complex, sophisticated nonlinear analysis. So for example, grid shells and all that stuff. And in those cases, you might not always use standard profiles. So you might want to define your profiles as manually. And in SOFiSTiK, we provide a number of options to do that. So we have a graphical preprocessor where you can model your profile. So any profile, like you can see here, this is a composite profile, which is has been set together with a couple of HEB profiles here. And that kind of profiles can be transferred to IDEA, but there is one thing you need to consider. So in SOFiSTiK, we provide two ways to analyze those profiles. So one is, we call it the thick-walled definition, and one is the thin-walled definition. So you can see it here. Thick-walled definition means you define your profile by the outer boundary, and all the analysis is performed based on surface integrals. But you can also define profiles using lines and welded lines which are welded together, and integral analysis is done on line or curve integrals. And for IDEA, if you want to transfer that data, right now only these thin-walled sections can be used. So you need to consider that when you want to transfer complex manually defined sections to IDEA. But if you do that, any kind of shape is possible and can be designed in IDEA. So I think that's a pretty nice feature. Yeah, so I'm already through my PowerPoint slides, and I'm switching now to the example. So the example I want to show you today is a steel frame which we set up here. We modeled that steel frame in SOFiSTiK SOFI Plus, and then I will show you how you can do the combinations and later on export that data to the subformat. So let me switch to SOFiSTiK SOFI Plus. So this is the preprocessor. I already set up that structure. So you see here all the members, and I'm just switching to 2D wireframe view. And let me just select one of these members. And then you can see the properties of that members. So for example, the cross section here is assigned, and we also have beam hinges, so moment hinges, so they are not transferring moments on that specific member here. So all that stuff can be modeled in SOFiSTiK SOFI Plus, of course. Also, we already set up a naming to the members that you can find them later on. So for example, we will see later on one of that interior nodes will be transferred to IDEA. So I think this is this one here. That node here will be then transferred to IDEA StatiCa. In addition to the structure, we also set up loads. So you can see here the loads. So we defined self-weight, additional self-weight, live loads, and so on. And as for the live loads, we also defined the live loads in a patterned loading scheme. So you see here different patterned loads, which we applied using so-called load distribution areas. So you define this load distribution area, which then transfers the area loads to the specific members in SOFiSTiK. Yeah, and once we set up this structure, we can export that structure to SOFiSTiK or to SOFiSTiK structure desktop, not to SOFiSTiK. So where you can define, the kind of elements being generated, but I don't want to go into detail here. I'm just switching now to SOFiSTiK structure desktop, where I already exported the structure, and I also already calculated the linear load cases here, which you can see here. So where you see self-weight, for example, you see snow loads, or you see these patterned loads applied to the members here, you see. Yeah, but in order to do a design, of course, we need to combine the loads. So we need to factorize the loads to get design forces. So, and in SOFiSTiK, there are different options to do that. So you can either do an enveloping, but for this kind of steel structure, and especially when you want to transfer the decisive forces of a specific member, it's better to do explicit load combinations. So, and we are combining the loads. But before I do that, just a few words on SOFiSTiK structure desktop, which you can see here. So in SOFiSTiK structure desktop, the entire analysis is organized in so-called tasks, which you can define totally freely. So you can, you see here, we have a couple of tasks for calculation, for doing the combinations, for local checks like buckling resistance. You can also define all the post-processing, so creating drawings or text outputs here. And I will do that later. You can also automate the export to the SAF here using a task. Yeah, and for the load combinations, I already inserted that task. So I'm opening up that task, and I already prepared here, in that case, manually 4 different load combinations. So with either live load being the guiding combination, or wind in one of the 2 directions being the guiding combinations. And then according, you can set the parameters down here according to these predefined factors, which are already set based on the design code, which is set up in the model. So this is one option. I already did that, and let me generate that loads in the model. So when clicking OK, this task is being executed, and then I can analyze those combined loads. So we created that combined loads, and then we can do the analysis of that loads, where you can where we provide different options. So for example, of course, linear elastic, but also second order theory, or fully geometric nonlinear analysis is possible. Yeah, I keep it with the linear elastic analysis right now. And once this is done, I can switch again to the visualization of my model. And now we see that we have now these combined load cases in the model here. This is one option. There is also another option, which I just only want to briefly strive here. So there's also the possibility that you can automatically select a number of members here. So for example, in this specific case, I selected 4 members which are joining at a node, for example, or at one connection. And then using that command, I'm not executing it right now, you are getting all the combination which are decisive for one of the forces of that member. So for example, there will be that combination which is decisive for the normal force, for the moments, and so on. So you can, using that feature, you can calculate the combinations which are decisive for a specific node, for example. I don't let this being calculated right now to keep it simple. Yeah, and once you did the load combinations, you do the analysis, then of course you might want to do some post-processing, but in order to do the design in IDEA StatiCa, you can now enter or add a task, which I do right now, called SAF export. And I'm personally, just let me check out the model. I want to pick this specific member here. Just let me select that member. This is node number 214. So you can see it here. I'm switching off the supports and hinges. So you see here, this is node number 214. And I will pick now this node number 214 first. So I just rename my task here. And double click the task. So, and in that task, I can either select the lines being transferred or the points. So I'm using here the points, 214. I can select that point here in that dialog. And yeah, then I need to select the load cases which should be transferred. So I'm just using those combined load cases which I already calculated right now. And in the options, I can specify what kind of coordinate system is being used or should be used in the SOF file, because in SOFiSTiK we are using a different kind of coordinate system compared to IDEA StatiCa. So there needs to be some transfer of the moments and also the geometry when you want to do analysis, when you do the analysis in IDEA StatiCa. So, but this setting is being taken care of here. And then I need to select a Excel file. There's also an Excel file here, but I select that connection, that Excel file here, which will be overwritten later, and then clicking OK, the file is being generated. Same can be done. I'm adding another task here, using another task for the SOF export for exporting the full model. So, and I'm just selecting, in this case, selecting all structure lines in my system, same result load cases. Options are the same, and I'm just adding here full model. All right, so we already automated that export now using that two tasks, and as already said, so in SSD, once you set up this workflow in the SOFiSTiK structure desktop, whenever anything changes, the loads or the geometry, you just need to recalculate the entire system, and also the export of the data is then automatically, or the export files are being automatically updated. So let me now switch to that file folder where I already exported that data, and let's have a quick look at the Excel file before I hand over to Adam. So you see here, this is the exported file where you will find where everything is organized in tabs. So you will find a tab for the material, you find a tab for the cross sections, and here the structural curve members. So these are all the members which are joining at this common nodes 214. And yeah, supports load groups, load cases, and here you will see all the load, the forces acting on that member. So you could also filter it and so on. So this is the information we are now transferring to IDEA, and yeah, I can hand over to Adam now.
Yes, thank you, Andreas, for your part describing SOFiSTiK, and I will now continue. Take the presenter and show my screen. So I'll continue with the story and start with the introduction to the Checkbot application of IDEA StatiCa that you can see right now. This is for the beginning, and to get familiar with the application, I have prepared the import of a SOF file of the whole structure that Andreas was showing to you in SOFiSTiK. It's already here, since the import of such a rather bigger structure takes approximately 1 minute to get it inside Checkbot. So I wanted to save your time and have it prepared. So let's have a look. You can see clearly the structure is there in the 3D window. You can, of course, play with it, select all its parts. On the left panel, there's a list of all the connections. If I click on this one, for example, which is number 301, it gets highlighted. You get the information about the connected members and so on. You can somehow edit this as well. And I can also, for example, highlight more of those connections and do some actions with them, like I can delete them, reset their settings, and so on. So this is how you handle the list of connections in the 3D model. About the imported geometry, if I, for example, select one member or beam of the model, I can also see the information. Some of them are grayed out, so they are not editable, like the begin node, the length of it, material. The cross-section, this can be edited, so you can further optimize the whole structure in the checkbot by, for example, changing the cross-section to another one. Or you can also modify the some of the parameters of the already imported cross-section. And then something that Andreas was pointing out, either the eccentricities of members are imported via the SOF file. If they are missing there from the global model, you can introduce them in the checkbot right away. So for example, if I select this wind bracing rod, which should be slightly to the up, moved about 10 centimeters, I can do it easily like this. So this is about the eccentricities. And then about intermediate nodes. This is also something that can be imported via the SOF file. If it is set in the original model, that means if you have, for example, this column should be a continuous one and there is intermediate node, you can merge the column into one piece by using the merge command from the top ribbon. Just select the other member and you can see now this is now one piece as a continuous column. So either you get this information already in the SOF file and you can see it right away, or you can do it then manually in the checkbot. So those are the options of editing the geometry and how to move around. And one more thing is about the loads. So there is a load configurator. So let me spend a few words on that. On the left side, on the left panel, you can see all the load cases and possibly load combinations that are part of the structure and the global analysis. And automatically by default, there is created one result class in the checkbot once you create a project here. And here you can find by default all the combinations. If there are no combinations, then you find all the load cases here. And this is what is used then for the analysis of connections and for the calculations in IDEA. If I select this result class, I can change the name and so on. And I can also turn on this evaluate critical effects. This is, in short, let's say a filter. That means if you have, for example, here, let's say 80 combinations, that's a lot. And also the calculation time of the analysis of each connection is rather longer because you have to calculate all those 80 combinations. But if you turn on this filter, this just filters out and doesn't use for the calculations those combinations that are not dangerous, and it rather picks up only the extremal combinations that are let's say useful or dangerous for the analysis and code check of connections. And of course, you can work with this as you wish. So you can, for example, delete the whole case, create a new one, and then select just those load cases or combinations you want to use. And you can work with this manually. So if I close this, if you want to read more, for example, about this feature, there is a help search window on the top bar of the Checkbot window, and our applications, which opens the website of IDEA StatiCa and its support center, and it directly shows you possible articles containing the information. So for example, about this feature, you can read this article where everything is described. So this is one useful tip for you. If you don't understand something here, you can find the help. Obviously, you have to be online for this, but I hope that's not a problem nowadays. And I think that's for the introduction to the Checkbot. Maybe one last thing, you can also check the internal forces here. You can draw them in the 3D model, and for example, if I highlight a few of the connections and I can switch to wireframe view, you can then browse all the load cases and combinations and compare maybe with the original model, or just, check if everything is all right and what is going on for each load case or combination. All right, that's it for the introduction. And now I will, let's say, simulate the workflow. Last thing that Andreas did was that he generated the Excel files, the SEF files containing the data. And I will now, this is what you can see on my desktop here. And I will now work with just one connection, the number 214 that he generated. So this is a new Checkbot window. I will generate a new project. I name it Steel Hole Connections, or maybe connection 214. And I can select the design code under which I want to perform the code checks of the connection parts. So for this time, it will be Eurocode, and create the project. So now I have a blank Checkbot application, and I can click on this icon, import SEF file, and just navigate to the XLS. Click OK. Now the data are read, or being read, and in 3 more seconds or something like that, we will see this connection in the Checkbot. So I will maximize this now, and this is the connection Andreas was focusing on. This is something that he wants me to work on, to design it and code check it. All right, so what I will do now as part of our workflow, you see this beam and this beam is separated with intermediate nodes, so I can easily merge them now by using the merge function. So I'll start with this one, then select another beam and select all these 5 parts of the beam. And I will also merge the column. You don't have to be afraid of losing the internal forces or the loads on the model. It is automatically regenerated according to the merging that you do. All right, so this is now prepared. What I would just do now is to select a node either from the 3D window or from the list. 214, and I can open it. Open means the application IDEA StatiCa Connection opens, which is embedded inside the checkbot, but you can also, of course, use it as a standalone application. So now you can see here is the column and the two beams and the side beams. About the geometry, here the comments are just that you can see this is all grayed out because it's part of the global model of the checkbot. So changing data here could corrupt the whole model here. So all the changes are being done in checkbot, in this case, not in the connection file. But I will show you at the end how you can overdrive this and maybe use a single connection project for optimization and experimenting and do whatever. So that's for the geometry. Then we have here the load effects. These are the load cases that are imported from the SOF file. You can see the description here as well. This is, for example, a combination or a load case representing the maximum normal force. There is minimum moment in Z direction and so on. You can see the values of internal forces. Those are the nodal internal forces that are actually results from the global model in SOFiSTiK. And on the in this tab on the bottom, you can see this is a visual check of unbalanced forces. This should be by the law of statics all zeroed, because that means the node is in balance, which of course is. And one last thing maybe for the geometry and the settings before I start the design is that there is a bearing member on each connection represented by this red square. This is automatically set to the strongest beam or logically by checkbot, but you can also change it to any other beam. After all, it doesn't matter. You can read about bearing member in the support center on our website. So here you can enter the keywords and articles will pop out. So I will continue now with the designing. So designing connections, we have more options. In IDEA Connection, we can use the manual operations. You can do it by this command or right-click on this operation and click New Operation. This provides you a list of possible connections, connection design, operations from the, let's say, complex ones that generate more things, means end plate, bolt, weld, cuts, etc. at one time, or a simple operations that produce just a simple cut or one bolt or whatever. So you have more options how to do things. So this time, for example, if I select a stop, I will say what is the default size of my bolt, which can be modified anytime for any operation or any connection between any beams. This operation is now generated. I can see its parameters and I can, of course, modify them. Say, okay, I want these end plates to be thicker. I want to move the bolts slightly to the up. I want to add one more row of bolts like this. Change the weld side, position, etc. So this is how we work with operations. And another possibility is to use the right-click button to generate connection between two members, maybe easier way. So I'll say, okay, I want to connect this beam to this column, and this connection design browser opens. That gives me possible options how to connect these two beams and generate, for example, also some strengthening panels, some stiffeners, some wideners in just one click. And I can filter this out. So for example, I want this connection to be bolted, and I know that is a shear connection. There is no moment, so I want to probably use just fin plate. And I can confirm this bolt, or I can add different size, whatever. I can of course change it here if I like later on by adding a new bolt assembly. But the fin plate is generated like this, and I can of course work with it, changing the parameters. So those are the options. And then one last but not least, I saved the best for the end. So I will clear all this and I will use the connection browser. This is a rather new feature. If I click on propose, that means show me possible designs, and unclick the filter here, I can see the possible design, let's say, templates that are saved in a cloud and that are proposed to you. It reads the geometry of your connection of the node, the profiles, its orientation, its number. There are some tolerances, and it just gives you some examples that you can use right away, so you can save time not adding operations one by one. So if I select one, click OK, again confirm the bolt assembly, I have at one click this node designed, and of course I can say, all right, this is good, but I want to, I don't know, have thinner plates here and different position of bolts. Everything can be edited as you wish. All right, that's the connection browser and how to call quick design proposals. And one more thing here I want to mention is that this is a fully finite element model that is based on shell 2D elements. And we work here with internal forces that are in the node. And for example, here we have a fin plate that represents a hinge, a pinned connection. That means the center of rotation is where the bolts are, right? And if I go to display, if I select one load case, display the wireframe model, and select here this beam and give you a side view, you can see the moment diagram. The moment is simplified, or simply the diagram generated from the shear force is linear distribution. And in the default case where the shear force sits in the node, we have a moment in the bolts, which is actually not correct, and we have to manually adjust this, because here the center of the rotation is in the bolts, meaning the moment of 0 is in the bolts as well. And how can I do this? I click on this member, go to its settings, and here I change the forces in from position or node to option bolts. So if I go back and again show the moment diagram. Now I have shifted the shear force into this position of the bolts, and so the moment diagram is changed and the zero moment is in the bolts. This is now the correct setting of this finite element model of this connection. All right, and I do the same for the other beam. And now this is prepared for the calculation. Of course, you can read about this forces in our support center and get more information and insight. Now I can push the calculate button. I will just do one trick to unselect 3 of the, or maybe 4 of the load combinations. So we don't have to calculate all of them and spend half more minute on this. By pushing the calculate button, the finite element analysis starts and it calculates all the selected load cases and it gives you the result. So now I can see on the first side, let's say, short version of results. First, that I have a visual control, a visual check. I can see my connection colored. Most of the parts are gray. That means the utilization of these parts is less than 60%. What is green is 60 to 95, yellow 95 to 99%. What is over is then colored in red, and that means it fails the code check and it is not strong enough. You can see this short version of or the summary of results here, and I can navigate to the check tab, and here I can see detailed results. So for plates, if I click on this stub plate, for example, it gets highlighted in the list and I can see the values of it. That means the stress, the maximal stress, the maximal equivalent strain, and this is now easily compared to the code requirements. Eurocode says for plates the equivalent strain must be less than 5%, which we fulfilled here. You can see there is some plastification, but still it's under the limit. For bolts, if I, for example, click on this bolt, I can see also the values of forces, the utilization ratio. If I click on this plus icon and right click to print the bigger preview, I can go one by one of the code checks that are required by Eurocode, see the values that are used for the code check, and I have a perfect control of what's going on. Similar thing is for welds. Again, I can see the values. I can see also the distribution of stress along the weld elements. I can show you how for example, this one, if I click on it, you can see the weld is divided into finite elements. Each of them has its own stress and strain values, and also, of course, the equations as per code. All right, that's this. And what more I can do is that this is a useful thing. I can have also visual control by checking the deformed shape of the connection, so I can see what's going on. Also a useful feature. Then the last step is to print out the report. Report is can be customized, so I can select what I want to have here. I can have a short report or very full report, and it contains all the necessary data. I can add bill of material and some of the code formulas, refresh, regenerate the report. So now it will be slightly longer. It will now contain the formulas from the code for bolts, also for welds, and also the bill of material that says how many plates of what sizes, and also some basic drawings. And I can save this into doc, so editable format, or PDF as I wish, or just print it out directly. All right, so I am now at the end of the journey of designing and code checking a connection. So once I'm done, I save my result, and I can see on the list that this is checked or marked with green mark, and I can see the summary of and the picture of the design here in the checkbot, and I can continue with other connections and finish the job. All right, and last thing I wanted to tell you is if you want to experiment or optimize a single connection, you can save it by using this command, export from checkbot to a single project. You can name it and save it to my desktop. So if I minimize it, now the file is here, and this is now independent from the checkbot project, and I can work it with it as with a single connection, open it directly in a standalone connection application. And now I can, for example, change all the geometry. I can say, okay, what happens if this is now tilted, and what happens if I change to another cross-section, and I can, do some, let's say, optimization and recalculation now and so on. So this is another possibility. And that is the last thing I wanted to show you. So I will now pass my word and presenter back to Andreas to conclude this webinar.
Okay, let me do that. Okay, yeah, already. Yeah, thank you, Adam. Yeah, we are already in the end. So finally, just from our side and IDEA's side, we just want to point you to where do you get more information. So as for SOFiSTiK, you, of course, you get most information on our webpage, SOFiSTiK.com, where you will find webinar recordings. So also the recording of this webinar will be available soon on our webpage. And also upcoming webinars can be seen here. Also interesting for you might be we have a number of user reports and interviews on our webpage. You can see here some examples, so you with some more detailed information about projects which has been done with SOFiSTiK. So pretty interesting, and it ranges, yeah, the entire range from modeling, bridge modeling to analysis of buildings and so on. So a broad range of applications. And finally, the trial version of SOFiSTiK. So on our webpage, you will directly see when you go to the downloads, you will directly see a link where you where you can download the trial version, and there you will also get an activation code for 30 days usage of that trial version. Yeah. Adam,
yes,
you want to say?
Yes, this is now my part. Sorry, yeah. I didn't fall asleep. I was just surprised. Yes, the same for our IDEA StatiCa webpage. We will also upload the webinar recording to our support center, also to our YouTube channel, so you can review or share it anytime, of course, for free with anybody. Also, we have the trial version that you can apply for on our webpage. This lasts for 2 weeks and has full functionality, so you can test everything, all our applications, all features, all for free, of course. And once again, the support center on our webpage, it contains a lot of information, not only webinars and these help articles, but also case studies, sample projects, and so on. So all free and prepared for you. And I think that's it for this slide.
All right, yeah. Yeah, so there are 5 minutes left. Should we go through a couple of questions which are showed up in the questions tab? So maybe I can also share my webcam again that you here. Or what do you think, Adam? So I'm just scanning them here. Let me see. Or,
Andres,
yeah,
I've got a question which I can take you straight to. There's 2 questions which are along very similar lines. What happens if the SOFiSTiK model changes? What is the process then to update the IDEA model?
Yeah. To be honest, that's something which we are still figuring out how it works. So right now, I'm aware that IDEA StatiCa already recognizes the GUID of the elements. So there is something, but we did some tests, and but what I saw right now, it didn't work out that well. But we need to investigate that further. So right now, I cannot say something. Cannot say that it works.
I can also continue with this question. So for now, it's just simple. So if there are changes or updates in the SOFiSTiK global model, for example, you change cross sections and some geometry, and then the loads and internal forces change, then basically what you do is that you re-import the whole data. So you generate a new SEF file and do it once again. But there is at least before we improve this cooperation, there is one, let's say, workaround that if you take just a part of the structure, update it and import it to Checkbot, it imports the update to the already existing Checkbot project. So for example, if you are interested in just a few connections, you don't have to delete the whole project, but you update just part of it.
But that's definitely some of the issues we still need to further improve in that cooperation. Yes.
Sure.
And we will do.
Yes.
Yeah. So there was another question regarding the braces, for example. So you have the diagonal braces, and if you enter an offset in IDEA StatiCa, so it will be a constant offset. And the answer here was already that, of course, if you have that diagonal braces, it's better to do that in the original model. So in SOFiSTiK, we can define different offsets. So you can either define it with offsets, or, and I'd like to mention that, usually they are also, if you want to account for eccentricities, also coupling conditions or kinematic constraints are being created. And this is also, however, something we still need to investigate. So right now, I think if you model rigid links, it's not working. So this is something we still are working on. Anything else here? Yeah, I think. Yeah, there's one I think I saw regarding EOM model, which can be exported. So let me just check the question. Yeah, what about exporting the connection to a separate IFC or 3D DXF DWG file for detailers?
That's a question for me, right?
Yes, yeah, sure. Sure, sorry.
I'm also browsing through them. So yes, so there is from connection, if you have a connection in the application, there is no direct export from the program to a 3D DXF or IFC file, but you can use the IDEA StatiCa online viewer. That's you open it in a browser. It's the viewer.ideastatiCa.com. There you upload the connection file. There is a 3D scene, and there's a feature that you can click on to generate a 3D DXF file that you can then open in your CAD software. It has some limitations, but it imports you the model of the connection to your CAD. So this is this rather workaround how to do this, and we want to work on this furthermore to make this available directly from the application.
Mm-hmm. All right, I think it's 11 o'clock now on my side. I think that's all. Or any questions you want to drive, Adam?
Yes, no, I agree. It's also in Czech Republic there is 11.
Yeah, in Czech Republic, yes, but there might be others.
It's the same time zone. Yes. All right.
All right. So, yeah, thank you all for attending, and yeah, wish you a nice day and a good week. Thank you from our side.
Thank you for your attendance, and see you next time. Have a great day. Bye-bye.